The topic of the webinar is big data and Hadoop technologies, and how do we enable our students to pick up the final year projects on big data and Hadoop. So we'll start with understanding what big data and Hadoop is, how broadly how the technology works. We'll also try to see some of the technologies which are attached to big data and Hadoop. So big data Hadoop is again a big field, and some of the technologies have been built around it. So those terms, we'll discuss about those terms, and then we'll discuss about some of the projects which can be picked up, and how teachers, professors can also engage in research activities around big data and Hadoop. And it's a very active community over the internet. There is a lot of research going on this community, and it's a vibrant place to be. So I'll share some of the links with you, along with some of the projects which can be created on big data and Hadoop. And students must be encouraged to work on big data, considering there are so many jobs and opportunities right now on big data. Okay, guys, so let's start. First of all, a brief about Monkfox. Monkfox is an education technology company. We create products and courses for higher engineering students. The focus of Monkfox has been to enable students to be more employable. So if there is a latest technology for which there are a lot of jobs, and a college or students want to do that course, Monkfox has those courses. We have trained more than 15,000 students across the country, and a lot of them have been placed at very good places like Amazon, Microsoft, and a lot of good product companies, along with a lot of service-based companies with decent packages and are doing well in their life. So this is brief about what is Monkfox. We are based out of Bangalore. Okay, now in case you have any questions, please feel free to ping me on the chat window. I am actively monitoring it. Okay, so what is big data? So we have all heard about the term big data a lot. What is big data basically? So just to give you an overview, till big data came into the picture, there was something called as a relational database. Oracle was a leader in relational databases, and the way it used to work is we used to store data in the form of tables, and these tables were related to each other by different constraints like foreign key constraint, primary key constraint, unique constraint. So these were typically called RDBMS or relational databases. With the advent of modern computing, with the advent of mobile phones, with the advent of internet, we have been able to, with the advent of internet, there was a lot of data that got generated over the internet, and this data was not necessarily in the form of relational database tables. So a lot of this data, for example, data coming from how many people tweeted or retweeted a particular tweet on Twitter, how many people liked a particular post on Facebook, how many people loved that post, how many people hated that post. This kind of data which was coming across from social media, from the web, and from many other sources. For example, another example could be data which is coming from the black box of an aeroplane, data which is coming from while from the error logs of a machinery. There was a lot of data which was getting generated, which was not exactly in the form of relational databases. Now, this data was it was too much, first of all, and this data had to be processed in some way or the other. And the conventional resources or the technologies which were used to process the technologies which were used to process our conventional data were no longer sufficient. So just to give you an example, the amount of data that got generated in the last 2 years over the internet has been equal to the total amount of data generated right from the inception of computers till today, till 2 years back. So that is the amount of humongous data that is being generated. So there was an automatic need of a technology which was there to handle non-relational databases, non-relational data in other terms, and that is how big data came into picture. So big data is similar to small data. The data is exactly the similar, but it's bigger in size. So big data is huge. If you talk about normal relational databases can be of 100 GB, 200 GB, but big data generally refers to the term where there is a petabyte of data, which is 1024 gigabytes and stuff. Now, if you have to handle huge amounts of data, like if you have to handle 2 petabytes of data, your conventional computation strategies and architectures will not work. You will take, for processing 1 petabyte of data, just for searching into a 1 petabyte of relational database, it will take you, say, days, and which is not the kind of processing that we want. Okay, so to process big data, we need different technologies. The idea is to solve some of the old problems quickly, and newer problems in better ways. Okay, so how do we handle this huge amount of data which is coming from sensors, from airplanes, from social media, from internet? How do we collect this huge amount of data and make sense out of it? Big data generates value from storage and processing of very large quantities of digital information that cannot be analyzed with traditional computational techniques. It can be analyzed, obviously, but it will take days or years. For example, just to decode a human genome, it took like 10 years to do it with existing computational techniques. And I don't think one of us has the time to do that. Okay, so we need better techniques to process this data. So this is what big data is. Big data is, I think you got what big data means. For example, I think I've already mentioned some examples. For example, Walmart handles more than 1 million customer transactions every year. 1 million customer transactions every hour. Please try and understand, each of these transactions are hitting Walmart servers, and they need faster computation, better architecture to compute this kind of data. Facebook right now handles 40 billion photographs on its user base. Humongous data, 40 billion photographs, just to make sense out of that photographs. And again, if you would have seen Facebook, it also tries to match faces. There's a facial recognition software which is being used. So that is again huge data. So this the third point is decoding the human genome originally took 10 years to process. Now it can be achieved in 1 week. So because of the architectural changes in big data, and because of the tools and techniques that have come in to support this big data, we have been able to decode this human genome information in like a matter of weeks, which is like great, which is an awesome experience. Any questions so far? Please feel free to ping me up. Let us move forward. Now, there are 3 main characteristics to big data. One is volume, velocity, and variety. By volume, I mean data quantity. By velocity, I mean data speed. By variety, I mean data type. Okay, what do we mean by volume? A typical PC, a typical PC in like 2000, year 2000 had a 10 gigabyte of memory, 10 gigabyte of storage. These days, like your laptops itself come with typically 1 TB or 2 TB of. Facebook ingests 5 TB of new data every day. 50 terabytes of new data is getting generated on Facebook every day in terms of likes, posts, comments, shares, videos, photographs, a lot of those things. So 50 terabytes of data every day. Boeing 737, which is a plane, where is such a large data stored? Okay, Alan is asking where is such a large data stored. See, Alan, the large data is stored in hard disks only. The problem with this kind of data is to process this data, relational databases are no longer sufficient. There is the difference between these two, normal data and this big data, has been this particular data, big data, is stored in files on hard disks. Typically, that's how it is stored. Relational database is more stored in tables. Okay, so the storage, the way they are stored is different, but that doesn't matter. It doesn't make a difference in the amount of space they are trying to occupy, because both occupy like more or less the same space. So 1 GB of relational database and 1 GB of big data will occupy the same space. The difference is computation. So 100 GB of relational database to compute 100 GB of, or probably let's take a bigger example, 1 petabyte of relational database to compute that, we will require approximately 1 week or 10 days. On the similar front, if we employ the big data architecture or the Hadoop architecture to process the big data, which is stored in files, it will take us probably 1 day or half a day. So the difference between big data and small data comes in the way this data is being processed. Was I able to answer your question? Alan, was I able to answer your question? Okay, till the time Alan is replying, if you have any follow-up, just ping it on the chat window. Okay, great. Okay, so we were talking about three main characteristics of big data, which was volume, velocity, and variety. And volume, I was mentioning that Facebook ingests 50 terabytes of data in different forms. Boeing 737 aircraft generates typically 240 terabytes of flight data during a single flight across the US. So you understand, over a journey of 1 hour or 2 hours journey, a Boeing airplane typically generates 240 terabytes of data, which is huge. So if you are like in a 2 hour journey, if you're generating 240 terabytes of data, you need to also process it, and conventional methods are no longer sufficient to do it. And one of the biggest creators of data today are your mobile phones or your smartphones. So the data they consume, create, sensors embedded into everyday objects, this is huge. Means be it your GPS sensor, be it your any other information which you are putting onto your mails, or you are chatting on WhatsApp, or your location and sensitive information, your data feeds, Facebook. Lot of this, you are even, say, for example, running healthcare apps, so they are recording your uh, heartbeats, they are recording your pulse rates, your walking patterns, sleeping patterns. Now this kind of data that is getting generated, and this is going somewhere, this is not getting stored on your phone. Everything is not getting stored on your phone, it is going somewhere, it is getting stored somewhere. And every human being now, everyone has a phone right now, and every human being carrying a phone, and the volume of data getting generated is huge. So again, first characteristic of big data, volume. Now velocity. Velocity means the speed at which this data is getting generated. Click streams and ad impressions capture user behavior at millions of events per second. So if you look at, you might have looked at Google ads, which you see on Google. You might have looked at on a lot of websites, there are advertisements which are coming. And another thing is, people are observing whenever they create a website, they observe the way you navigate through a website. So they need to capture your mouse movements, as well as they need to capture the way a user experience works, so that they can take that feedback and modify their website. Okay, so this captures, again, they take millions of events per second. Every user which visits a website, their navigation through the website is captured, which is again huge amount of data. Stock trading, uh, New York Stock Exchange, Bombay Stock Exchange, millions of people are trading these stocks every second, every day. And the amount of transactions and data that gets generated is huge. And then there are companies who crunch this huge amount of data to predict how the market is going to flow. So it might be a financial company like Morgan Stanley, or a financial company like Goldman Sachs. These are the companies who are crunching all these numbers and trying to predict how the market will grow, and that's how they make money. uh, Machine to machine process exchange data between billions of devices. A lot of phones, servers, billions of devices exchange data between each other. Infrastructure and sensors generate massive log data in real time. If probably your sensor is not working, then it generates log messages which allow you to debug, which allows the developers to actually debug why the sensor is not working, or why an app is not working. So again, this data is coming from your phone, or your car, or any such electronic device. These devices generate a lot of logs. And online gaming systems support millions of concurrent users, each producing multiple inputs per second. So these are, I think you might have seen in the last 4 to 5 years, online gaming and gaming on the Wi-Fi has gone manyfold. So people are just joining in into game rooms and they are concurrently playing, recording these impressions every second of millions of gamers across the world. This is the kind of velocity at which the data is getting generated. So the second most important part of big data is velocity. First one, volume. Second, velocity. Third one is variety. Getting generated is not just text data. There is a huge amount of non-text data as well that gets generated, like audio, videos, unstructured text, log file data, social media data. All this is basically non-structured data, which generally is not in the form of text. Now, how do you store this kind of data in a relational database, in a MySQL database? You can't. Okay, traditional database systems were designed to address smaller volumes of structured data, fewer updates of predictable, consistent data structures. See the second point. See, the second point clearly mentions the properties of a SQL or a MySQL database or a relational database. They were designed to address smaller volumes of data, fewer updates, and consistent data structure. That means relational database always knew the kind of data which is going to come. You cannot create a relational database for one type of data and then adapt it to handle, say, audios or 3D kind of data. No, you can't. Big data, you can. Okay, so a big difference between the kind of data these big data architectures are supposed to handle. Big data analysis includes different type of data. So data analysis, the kind of like, for example, Facebook runs a lot of big data analysis on your photographs. It runs a lot of analysis on what are your preferences, what do you like, and suggests ads based on these things. Okay, so a lot of variety of data that big data is supposed to handle. Okay, any questions so far? Okay. Am I going too fast, too slow, or is it good enough? Should I keep the pace? Any input from the audience? Are you guys following what I'm saying, or I'm going too fast? Alan, Mr. Tejas. Okay, we'll move forward. Now, why big data? Growth of big data is needed because there's an increase of storage capacity. The space or the storage space cost has gone down. Increase of the processing power. So if you see the kind of CPUs or chips which are coming up recently, they have been very powerful. The kind of chips which you used to get on your laptops 5 years back now are coming in your mobile phones. So the processing power has gone up drastically. The cost per unit of processing power has gone down. Availability of data, different types of data. So with a lot of new data type formats like GIFs, JPEGs, your audios, different kinds of audios, MP4 audios, then your videos, a lot of different kind of data is getting available, and because of which there is a huge variety of data which is getting generated. So every day we create 2.5 quintillion bytes of data. 90% of the data in the world today has been created in the last 2 years alone. So 2.5 quintillion bytes of data, which is, I don't know, I even don't know the number of zeros it will have. So this is the data that we create every day today. Okay, and it is set to increase. Okay. Okay, now let us we talked about big data as a whole, and big data is nothing but huge amounts of data. Okay, they now considering what big data is. Now we have understood the various characteristics of big data and what big data is. There are frameworks which have been developed around big data to handle this kind of data. Those frameworks are Hadoop, which involve MapReduce, HDFS, which is distributed file system, uh, Spark, Flink, Storm, Samza. These are some of the frameworks which I suppose a lot of them you might not have heard before. So I think you might have heard just Hadoop, MapReduce, and HDFS, which is Hadoop distributed file system. And Spark, some of you might have heard about Spark, but the rest of the three you might not have heard. These are the most popular systems. Hadoop and Spark are the most popular systems, and there are other frameworks as well. So just to, I should just give you a differentiation between, I just gave you a differentiation between what big data is and Hadoop is a framework. So when we talk about a course on big data and Hadoop, that means we are handling big data using Hadoop. There can be a course on big data using Spark as well. So Spark, Hadoop are frameworks. Big data is a tech. Big data is more of to do with the kind of data that is getting generated. Okay. How is this? I think Mr. Tejas is asking, how is this large data transferred? Sir, it is, again, I told you, transferring is through online, your internet speeds. Because if you see across the world, with the advent of 3G, with the advent of LTE, with the advent of 4G, the internet speeds have also gone up. Okay, so generally, when such huge amounts of data is being transferred, there are basically huge bandwidth. So let us assume in a city there are a million mobile phones, and there is one internet service provider, say for example Airtel, and each of these mobile phones has a 3G connection, and there is that service provider called Airtel. So now a million mobile phones use their 3G connection to send small amounts of data. That is not a problem because every mobile generates decent amount of data which is sent to the service provider. Now this data coming from million devices across the city becomes so huge at the internet service provider's end. Internet service providers have huge bandwidths which are not available to individual people. So internet service providers are able to send this data across because of their huge bandwidth. The modes of transference of data don't change. They still remain the same. Internet speeds have gone up. Okay, and sometimes in a local, say in a company where a huge amount of data is being transferred, they use local area networks. So local area networks are again much faster, much faster. They don't go through the general web. So there is no difference in the, even in the transference. The big data doesn't have any difference in transfer, the way it is transferred and the way it is stored. The only difference is how fast can you process it. Did I answer your question? Okay, by the time Mr. Tejas is coming back to me, let us start because there is a delay in the response. Okay, let us start. So we discussed the top frameworks of big data. Now this is the bigger picture. This is the bigger picture of big data. In a bigger map of, in a bigger scheme of things, how in an industry big data is operated, and where do actually these technologies kick in? Okay, so you see there are four verticals. One is big data sources. So big data sources is basically from where the data is getting generated. Okay, and big data sources are typically from where the big data is getting generated. This data is generally raw, and excuse me, I think okay, Mr. Tejas replied. So I didn't know if you guys are hearing me or not. If there is a problem, okay, I think you're able to hear me properly. So I'll just continue. So we see four verticals here. One is big data sources, which is from where the big data is getting generated. Second is big data transformations. That means there is some processing which is done on that big data to make it somewhat processed. It is again there is a huge amount of chaotic nature in that data, but still it is transformed to certain level. Then it goes to the big data platforms and tools, which includes your Hadoop, MapReduce, and goes through analytics, big data analytics, and it is displayed by the analytic applications. Okay, so I'll just go through each of these. So big data sources, we know our mobile phones, our social media platforms, our aeroplanes, all these things are actually big data sources. So this is from where this is the place from where big data is getting generated. This raw data, this is actually raw data. It is in various forms. It can be in video form, text form, simple notepad forms, and videos form, any form. This data is like literally raw, and it can be in any form, and it is then transferred to big data transformation. Big data, depending on the kind of data. So videos are processed separately, text is processed separately, and images are processed separately. So I'll just give you a very good example. So for example, I want to know that how many times on Facebook somebody has been talking about our PM Modi, for example. On Facebook, how many times, either through a comment, either through say a post, or either through say on an image somebody has written something about PM Modi, or say in a video somebody is talking about PM Modi. So there are four kinds of sources here. Okay, now I want to know, I'm the founder of Facebook, and I want to know how many people are actually talking about PM Modi. So this gives me a huge idea about how popular he is, what is the perception of the market, and those kind of things. So this data, I need to figure out this data. Now, how do I do it? I first go through all the Facebook feeds and collect everything where there is a mention of Prime Minister Narendra Modi. Now, this is kind of raw data. I will have data in videos, I will have data in images, I will have data in comments, a lot of these things. This data I send to my second big data transformation layer, where this data is segregated into different parts. So the video part, all the videos that have mentioned the name of Prime Minister Modi are segregated into one part. All the images are being processed into another part. All the text files are processed into another part. The comments are processed into another part. Posts are processed into another part. So we get all the data to be processed. And mind it, this I'm talking about the world. So I'm gathering this data from all the post images, videos which have been posted in the last 1 day or 2 days across the world. So this data is huge. So some amount of segregation here allows me to get a transformed data, which is in some form, and I put this data into some kind of file. This file will be approximately a petabyte of file. This file will be huge. It will have information from all the different formats of data which I've collected. Now this transformed data is transferred to the big data tools. Now here is where the magic actually happens. This is where, from that unstructured data, Hadoop, MapReduce, Pig, Hive, Zookeeper, Cassandra, and any, depending on the kind of tool you use, these tools actually extract the mention of Prime Minister Narendra Modi from these different kinds of formats of data. And the trick is, they do it, they have their own architecture, and they do it much faster than if you put all of this data into a relational database and process it conventionally through older methods. If you do that, you will take approximately 1 day or 2 days to do it. Facebook does it in a couple of minutes by using big data at its backend. If you see on your Facebook, on your right hand side, you would find something as 65,000 people are talking about this, 100,000 people are talking about this. It is running big data at the backend. That is how it does it. There is no other way. Mr. Keshav, is there a question? Okay. Now, when this Hadoop and MapReduce have processed this data, they send it to big data analytics. So there's a lot of analytics which run on this processed data. Now the data is processed to a lot of extent, and then this data is displayed on various platforms. It can be queries, it can be reports, data mining, or OLAP servers, whichever the way you want to use the analytics. It depends on you. So this is how a typical picture or the flow of big data is in a conventional industry setup. Any questions till now? I'll just wait for 1 minute to handle if there are any questions. Okay, so let me move forward. If there are no questions, then I will simply move forward. Okay, now this is a picture I have just kept for completion's sake. You might have heard some certain number of terms, you might not have heard certain number of terms, but these are various technologies which support big data. So I talk about Flume, I talk about Scoop, Zookeeper, HDFS, and mind it, these all technologies are not used in one single system. So depending on the kind of usage, so for example, if you look at HDFS Hadoop distributed file system, that is at the base. On the top of it, it uses Yarn, which is they both of them work in sync. On the top of that, you can use either Oozie or Pig or Mahout or R connectors or Hive. It depends on you. So these are optional. So somewhere down the line, when you are studying or researching about big data, you will hear a lot of these terms. And I just wanted this picture to give you a sense of where these technologies fit in. Okay. If you don't have any questions till now, this is the Hadoop master slave architecture. Now, prominent framework or the most popular framework to handle big data across the world has been Hadoop. Okay, and somebody, I think you might be surprised till now you must be surprised because what I have told you is big data is so huge, but still it is processed so quickly. Conventional data is so less, and why big data cannot be processed by conventional methods. So you might be wondering what enables technologies to actually process this data and in such a short span of time, like process petabytes of data in such a short span of time. So Hadoop being at the forefront of big data frameworks, Hadoop actually gives us an architecture which is like, this is the kind of architecture. So there is something called the master node or the name node or the job tracker, and it has like multiple slave nodes. As I took the example a couple of slides back, Facebook trying to collect mention of PM, how many times somebody has mentioned Prime Minister Narendra Modi in their videos or comments. Now, this data, when it goes to a Hadoop framework, it is first divided into tasks. Okay, and these different tasks are assigned to different slave nodes, And the task of name node is basically to track which part of the work has been assigned to which slave node and whether they have done it or not. So this data, first of all, is parallelly distributed across all the slave nodes. So one second, guys. Okay. So the way big data is handled so quickly is because it depends on our architecture, which involves parallelism. Okay. All these name nodes, slave nodes run on Hadoop distributed file system. Okay. And the data is distributed to all these slave nodes parallelly, and they operate on each of their data parallel. Okay. And name node tracks which data is being processed, and if there is an error in processing of one of the slaves. If it does, then it takes the work from that slave node and assigns it to somebody else. So this is a typical Hadoop slave architecture. I don't want to go too much into detail about what a data node is, what a MapReduce is, or task tracker. But in general, you should understand how the data coming inside an Hadoop architecture is processed. Okay. So first, the data comes in. It comes into the name node. Name node divides it into multiple sets, smaller tasks, sends or assigns these smaller tasks to its slave nodes. Then these slave nodes, once they are done, they send that data back to the name node, saying that the data is done. The name node's task is to basically combine that data again back into that single job and return the output as a single output of processed big data. So distribution of tasks, processing, combination of tasks again, and returning it back. This, what I told you just now, is one of the most famous techniques of in big data, which is called MapReduce. Okay, so first map it to slaves, then reduce it back to the single problem. Any questions till now? Okay, I guess there are no questions, so we'll just move forward. Now we have briefly talked about what big data is. I think everybody understands now what big data is. I briefly talked about various names of various frameworks, technologies inside big data, and given you a brief idea about what is Hadoop, what is a Hadoop architecture, and what do you mean by MapReduce. I think this is what I have covered till now. Now I'll just cover more in terms of what are the kind of projects which students can pick up, and what is the kind of research which is going on across the world on Hadoop and big data. So big data impact across the world. Big data is the second most impactful technology in the world. Okay, the first one being mobile and internet, and big data is being the second. So that's how impactful big data has been across the world. These are the typical job trends. The data is till January 2015. The jobs have increased in exponentially in big data and even in data science or data analytics. So doing these technologies or knowing about these technologies is a boom right now, because a lot of almost every company is now working on big data. They have a big data server. They need big data developers who know how to operate on big data. So the jobs in this sector are increasing exponentially even now. Okay, now please discuss basic and trending projects in big data. Yes, Mr. Tejas, I will come to the basic and trending projects in big data. Okay, I think for you, those of you who don't know, so this whole webinar, the purpose of this webinar was to encourage more and more students to take up final year projects in big data, and final year projects are really important. So the professors need to encourage students to take up these final year projects and to work on big data more and more. And since final year projects are important, because in the interview preparations, the interviewers also ask a lot about what you have done, and if you have done a project on big data, I think it's a very positive impact, at least a very positive impact on the interviewer. There are higher chances of you getting the job. Okay. Okay. Now, problems with the final year projects. I think most of the students copy their projects. There's a fear of technology in students. Not a lot of companies offer meaningful internship for learning. So the forms that you must have filled, there was somebody who asked me a question saying that where can the students go and work on big data projects? So I think, see, sir, a lot of these companies who are working on big data, they don't want amateurs. They don't want people who have no experience. So it is hard for students to get internship on big data. The best thing a student can do is first learn the technology, in that technology, and then only he'll be eligible for an internship or to get a work in a company. Okay, so I think students, to remove that fear from students and make them learn a particular technology is what will make them do their own projects. Okay. So because of these problems, we found that students are really not doing their final year projects, and I think Monkfox can help them create their own projects on big data. So we launched our final year project program on big data, which has both the modes, classroom mode and online mode. Students learn about big data and Hadoop. They learn about the technology. They create their own Hadoop architecture. They install their Hadoop architecture. They solve simple problems, like I told you, the problem of, say, filtering out tweets, filtering out data from Facebook. These are some of the kinds of problems that students solve in the class. Then, because the technology fear has already decreased in them, students pick up their projects and create them in the class using big data technology. All the projects in our class are graded and reviewed. There's no chance of cheating and copying the project because the students are doing the project in the class in front of the expert. Mock interviews on projects similar to what is asked in placements. So generally, students get to are asked a lot of questions on the final year projects that they have done. So in our final year project program on big data, the expert conducts mock interviews as well, and we ask them questions about what they have done, how they have planned about it, ask them questions about HDFS, MapReduce, and those kind of questions, which are generally will be asked in interviews. And of course, at the end of it, the certifications are provided. So with the Monkfox final year project program, the students will be learning all these technologies. They will be learning big data. They'll be learning Hadoop. Hadoop distributed file system. They'll be learning what is MapReduce and coding in MapReduce, which is typically nothing but coding in Java. Spark, they would learn Spark, Hive, and Pig. So Hive and Pig are more or less used for querying the big data. So students will be learning both of these technologies. Hive is getting though more popular than Pig. And they'll also be learning some data science analytics, where they'll be analyzing this huge amount of data. And because data being processed and not being analyzed doesn't make any sense. So the data which is coming out from the Hadoop system needs to be analyzed. So you need to know a lot of classification and data science techniques in order for that data to be useful. And you will be doing projects in the class. Okay, so you will be creating some of the projects from your own self, and you will be creating, delivering and seeing those projects in action. Now let us see some of the projects of which the students will build in the class. Big data and Hadoop final year projects, some of the things which students can take up as a part of big data and Hadoop. Web page rankings using Hadoop. Now, if you have seen how the Google is working these days, the Google's instant search, it is based on big data. So the way millions and millions of pages are being ranked based on various parameters uh, is what is handled by big data, and that is done so quickly because of the backend Hadoop infrastructure. So web page rankings using Hadoop. This is one of the projects. You don't have to pick a million pages. You can pick, say, 1,000 web pages, 1,000 websites, and rank them according to various parameters which you think. It can be a very good project for a final year student. So basically, you will be actually creating a search engine which is pretty quick by using Hadoop at the backend. Twitter data sentimental analysis using Flume and Hive. Now, Twitter data, there's a lot of, I think, emotions which are getting displayed on Twitter. There's a lot of people are posting and telling about how they feel about certain things on Twitter. So Twitter is a very good handle to figure out how the mood of majority of people is on a particular incident or an event. So doing a sentimental analysis is nothing but trying to gauge the mood of the audience. So doing a sentimental analysis on the Twitter data reveals a lot about the mood of the people, and this is a very good big data Hadoop project. Healthcare data management system using Hadoop ecosystem. There can be 1,000 parameters for a particular patient, and can you, over a period of say 5 years, how the patient's parameters or vitals have changed can be very easily stored and run on a Hadoop system. Sensex log data processing using big data tools. So Sensex generates a lot of data. You will get Sensex data past 10 years of Sensex data on the web. You can pull out that data, try to make sense of that data. And mind it, you can always do or process this data by using relational database, but this is not the part, because when you crunch 10 years of market data using a SQL database, it will take you a couple of days for the process to run. You need to put it into a Hadoop architecture, and then it will take half an hour to 15 minutes to process the whole 10 years Sensex data. Okay. A priori algorithm implementation using MapReduce. So this is a very famous algorithm used for finding patterns. So a priori algorithm, you can use MapReduce on Hadoop to implement this algorithm. Uber data analysis using Spark. So Uber is generating a lot of data based on its driver locations, its consumer locations. What is the which are the areas where lesser driver frequencies there, which are the areas where higher driver frequencies there. A lot of this data can be analyzed using Spark, and you will get some of this data on the web. Okay, counting hashtags on Hive. So Twitter, there are certain things which trend on Twitter because of hashtags. You can count those hashtags using Hive and give an output. Web article classifications and summarization. So if you talk about, say, you pick up a topic XYZ and you basically classify those articles and summarize those articles, and you can try to figure out a summary of those articles. This could be a very good big data and Hadoop project. Any questions till now? Okay, let me move forward. I think Mr. Tejas, here, this is the slide where I discussed the basic and some of the advanced projects which can be done on big data. I think I answered your question. Okay, system configuration and software for big data. Now, you need a minimum 40 GB of hard disk, which is, I think, almost everybody has, or in fact, 40 GB of free hard disk space. You need at least 8 gig or 8 GB of RAM. So if your RAM is like less than 8 GB, go to the vendor. I think your RAM can be extended. Put another RAM card into it, and you're good to go. But you need at least 8 GB RAM on your system. You can install, you can go to the site which is mentioned here, which is hortonworks.com, where what to take in hand first. Okay, Mr. Tejas, let me answer your question once I'm done with this. You can go to this website called hortonworks.com, install Hortonworks Sandbox, and this sandbox will come together with the Hadoop file system, Zookeeper, HBase, Pig, Hive, MapReduce. So automatically, this Hortonworks Sandbox will install a virtual machine on your laptop, and it will install these things together. So you don't have to worry about installing each of these things separately. Okay. Recent research work in Hadoop. Now, I mentioned about some of the projects which are going on, and there is a lot of research. The Hadoop community is a very active community, and there is a lot of research which is going on in this community. Some of the research includes processing performance on Apache Pig, Apache Hive, MySQL cluster, methods and system for educational networking, efficient traffic speeding for forecasting based on massive heterogeneous historical data, set-ins, storage efficiency techniques in NoSQL database for cloud-based design. So there are, I've just picked up some 8 or 9 recent research areas on Big Data Hadoop. But if you go to the site mentioned at the last, which is project.com, Hadoop thesis, this will give you all the recent papers which have been published and the recent areas of research which is going on Hadoop. And mind you, it's a very active community. Right now, Hadoop is being researched like anything across the world. New architecture forms are being designed, and the efficiency of Hadoop on various systems is being tested, various networking platforms it is being tested. And I think it's pretty interesting from the research point of view. Okay, so here we come to the end of this webinar. I hope you enjoyed the webinar. If any one of you wishes to conduct the final year placement, final year project on big data and Hadoop for your students, please you can contact us on these numbers. You can email us. Also, if you can like our Facebook page, which is monkfox.edu, and we have started a new channel on YouTube, which with the name as Monkfox Placement Preparation Corner, where we keep posting free placement videos for students to like. Please subscribe to this channel. You will keep getting updates about the new videos which we are posting, and you will also keep getting updates about the new webinars which we have been planning over the next few days. I think if you have any questions, please shoot at me. To answer Tejas' question, see, Tejas, there are a lot of ways where you can start learning. There are a lot of online resources, free online resources as well as paid. But I personally think that see, there's if you go look at Edureka, I think they typically charge you like too high for a particular big data course, and I don't think really that paying such a huge amount is really worth it. You can start. What I'll do is I will send you a mail with some of the starting sites where you can start the installation, start writing your first programs on Hadoop, and that will actually help you get kickstarted. And then you will understand that you can do those things even just by reading free content. So there's like that is something which I can do. So as of now, I don't think you need to spend huge amount of money for learning big data. I will send you a mail with some links with which you can start doing it. Keshav, yes, did you have a question? Any questions anybody has? Yes, Mr. Keshav, Thor is great. So, sure, Alan. I will send you the link to all these things. We'll also send you the recording of this session, um, and we'll also send you places where you can start learning. So please do feel free to contact us, and do subscribe to the channel and like the Facebook page to get regular updates. I'll just wait here. Those who don't have any questions, they can leave. I'll just wait here for another 2 or 3 minutes and see if there are any more questions coming, and then we are done with the webinar. I hope the session was helpful for you guys.